If you did not remember the absolute value inequalities, this is a great refresher right here. The absolute value of x minus a is less than or equal to d. The absolute value of x minus a is less than or equal to d, is going to be less than, and it's going to be an overlapping. So there's our answer right there. The next one, if x minus a, the absolute value that is, if the absolute value of x minus a is greater, then you're going to have either or as part of your solution. Either or as part of your solution. Okay, we've got a word problem here. A large manufacturer hired a quality control firm to determine the reliability of a product. Using statistical methods, the firm determined that the manufacturer could expect 0.35% plus or minus 0.17% of the units to be defective. If the manufacturer offers a money-back guarantee on this product, how much should be budgeted to cover the refunds on 100,000 units? Assume that the retail price is $8.95. Will the manufacturer have to establish a refund budget greater than $5,000? Okay, what I want you to do is I want you to think about rewriting this as an absolute value inequality. An absolute value inequality. Okay, we have to determine the variable we want to use, and we are talking about We're talking about if the manufacturer offers a money-back guarantee on this product, how much should be budgeted to cover the refunds? So we're talking about money. How much money should be budgeted? And how are we going to get to money? What is varying? It looks like our high and our low is 0.17 through 0.35. So you could expect 0.35% plus or minus 0.17. Okay, so plus or minus 0.17. So less than or equal to 0.17%. I'm going to leave the percent there for now. We're going to end up having to move the decimal to get rid of it. So our starting point, our from 0.35%, so we can call this, is there a variable that they're making us use? Let's look. Will the manufacturer have to establish a refund budget greater than $5,000? Well, we're talking about the rate being a certain distance from another rate. So I'm going to call this R, because this isn't units. This is going to be R. And then, of course, distance needs to be positive. So let's move these into decimal values. So 0.35% is 0.0035. So R minus 0.0035 is less than or equal to 0.0017. We just move that decimal place over 2 to take care of the percent. Now I'm going to rewrite this. I'm going to have negative 0.0017 is less than or equal to R minus 0.0035, which is less than or equal to positive 0.017. We're going to add the 0.0035, giving us 0.0018 is less than or equal to R, which is your rate, is less than or equal to 0.0052. If the manufacturer offers a money-back guarantee on this product, how much should be budgeted to cover the refunds on 100,000 units. So we can expect a defective rate between 0.0018 and 0.0052. So that would be your 0.35% plus or minus 0.17%. That's our rate of defect. However, we want to know about the money. So if the rate of defect is based on, let's see, on 100,000 units, 100,000 units, we're going to have to multiply 0.0018 defective rate times 100,000 units. So that'll tell us the number of units that are minimally defective. And when I take that R times 100,000 units, I'm going to get X number of units. So I go from a percent to the actual number of units. And then I'm going to, of course, have to multiply this by 100,000. So we get 180 defective units for a minimum. And 100,000 times 0.0052 is 520 defective units for a max. And then the cost, we're going to come over here, the cost is not 180 or 520 because that's the number of defective units. It's $8.95 per unit. So $8.95 per unit. And when we take 180 times $8.95, we get $1,611. So that's the minimum cost of the defective units, is less than or equal to the cost, which is less than or equal to $4,654. So when you're planning on producing, a number of units is going to be defective, and those number of units is going to have a cost associated with it because you tried to produce them. Even though they were defective, you still had a cost in producing defective units. So the fewer defective units, the lower the cost. The higher the number of defective units, the higher the cost. So if you are a company, what you want to do is you want to know your minimum and your maximum. And then you're likely going to lean towards the maximum number in your budget so that you're accounting for the worst case scenario. Worst case scenario. Okay, you could try the next one. Or I believe you might be able to find another one in your homework. You might be able to find another one in your